Hello? Yes, this is just a summary of the previous lesson. A summary of the previous lesson on oxidizing agent and reducing agent, and the calculation of the oxidation number. So now, at the end of this lesson, you should be able to understand. You should be able to understand what is a reducing agent and oxidizing agent. Then you should be able to know to identify a reducing and an oxidizing agent given in a given redox equation. So now, then after that, you should be able to know how to calculate the oxidation number of an element or of an element in a given compound. Starting again, during our last previous lesson, we mentioned that a reducing agent is a substance that reduces another substance and a redox reaction and is being oxidized. Whereas an oxidizing agent is a substance that oxidizes another substance in a redox reaction and is being reduced. What do I mean by this? When two reagents or reactants are reacting, one must be a reducing agent and one must be an oxidizing agent. The one that is an oxidizing agent will oxidize the other reactant and itself being reduced. In other words, the one that is a reducing agent will reduce the other reactant and itself being oxidized. This is an example of it. I'm talking of iron. I'm talking of zinc plus copper ion reacting to give zinc, iron, and copper. Based on your knowledge on the reactivity of metals, the reactivity series of metals, you know, zinc is more reactive than copper. In that case, zinc will have to displace the copper. Here, zinc, based on the knowledge of the oxidation number, assigning oxidation number to atoms, you know that zinc, any element in its free or in neutral state, has an oxidation number of 0. Zinc here is 0. Zinc is oxidized here to +2. The oxidation number of zinc here is +2. In that case, zinc has been oxidized from 0 to +2. There is an increase in the oxidation number. On the other hand, copper ion that was reacting, copper 2 ion that was reacting, has a charge of +2. It has been reduced to 0. Here, based on the definition we gave, because copper has been reduced to from +2 to 0, we now said zinc is the reducing agent that has reduced copper from +2 to 0. Again, zinc that has been oxidized from 0 to +2. We now say copper ion is the oxidizing agent because it has oxidized zinc from 0 to +2. Since our definition says a substance that oxidizes the other one and is being reduced, copper oxidized, copper 2 ion has oxidized zinc and is being reduced to 0. On the other hand, zinc has reduced the copper 2 ion to 0 and is being oxidized to +2. We now say an oxidizing agent is a substance that oxidizes another one and is being reduced. An oxidizing agent is a substance that oxidizes another substance and in a redox reaction and is being reduced. Meanwhile, a reducing agent is a substance that reduces another substance in a redox reaction and itself being oxidized. Again, we have to go to the calculation of oxidation number in redox reactions. You know that oxidation number, which initially were called the valency, this is a number that is given or is assigned to an element. It is either assigned to an element or a radical. A radical is a polyatomic ions. This is a number that is assigned to an element or a polyatomic ion to show how many electrons it has gained or it has lost. These numbers are related to the group number of the element. For instance, those in group 1 will have an oxidation number of +1 because they have given out, they lost 1 electron to obtain an octet of electrons. Similarly, those in group 2 have lost 2 electrons to obtain an octet of electrons. And those in group 3 have lost 3 electrons to obtain an octet of electrons. And group 1 will have +1, corresponding to the number of electrons lost. Group 2 will have +2, corresponding to the number of electrons lost. And the group 3 will have +3, corresponding to the number of electrons that have been lost. Again, the oxidation number of a monatomic ion is the charge on the ion. Remember, there are many. Remember that the atoms, the monatomic ions are atoms like hydrogen ion, sodium ion, chloride ion, aluminum ion, ion 2 ion, ion 3 ion, boron ion, and so forth. All these ions that have a charge on them. That charge is equal to the atomic number of that element. Then polyatomic ions also have charges. For example, the sulfate has a -2. Carbonates, they have a -2. Nitrate, they have a -1. Chloride, they have a -3. They have -3. Many others, phosphate, they have a -3. All these are assigned to them based on the number of electrons that have been lost or they have been gained. The next point on this is that elements with more than one oxidation state, for example, we are talking of transition elements. They have variable oxidation states. So this element in their compound are represented by a Roman numeral. I'm giving an example of copper 2 sulfate. This copper 2 sulfate, there is copper 1 and there's also copper 2. Copper 1 and the copper 2, the only way to differentiate them, because they have many oxidation numbers, is by putting it in a Roman numeral. It is copper 2 sulfate here. Iron has 2 oxidation numbers. Iron is a transition element. It has +2 and it has +3. In a substance like this, rust, iron 3 oxide, we will have to put it in a Roman numeral in order to show that this is the oxidation number. There are some rules set aside by the International Union of Physical and Applied Chemistry, the IUPAC, in calculating oxidation state. Some of these rules are: 1, an element in its free state has an oxidation number of 0. It could be like sodium. Oxidation number of a neutral molecule, let me say like chlorine molecule, because chlorine is a diatomic molecule, or like hydrogen. Hydrogen is a diatomic molecule. So in that case, the oxidation number is 0. Group 1 elements, as we said earlier, have an oxidation state of +1. Group 2 elements have an oxidation state of +2, corresponding to the number of electrons that have been lost. Group 3 elements have oxidation number of +3, corresponding to the number of electrons that have been lost. All halogens, that is group 7 elements, have an oxidation number of -1, but positive when combined with oxygen because of the electronegativity due to their electronegativity. Oxidation number of an ion or a radical, that is a polyatomic ion, is equal to the charge on it. We are talking of the carbonates. Carbonate is -2. That is the -2 indicates the oxidation number of that polyatomic ion. Oxidation number of oxygen is -2, but it is -1 in a peroxide. Oxidation number of fluorine is -1. Oxidation number for neutral compounds is 0, as we said it. For example, iron bromide. The iron bromide, the oxidation number for a neutral compound is 0. The total of it must be equal to 0. The sum of the oxidation, the sum of oxidation number for a polyatomic ion is the charge on it. The charge on it indicates the oxidation number. A recap of this lesson: an oxidizing agent is an agent that oxidizes another substance, and itself being reduced. A reducing agent is a substance that reduces another substance in a redox reaction and itself being oxidized. Group 1 elements, they have a charge of an oxidation number of +1 corresponding to their charge. Group 2, a +2 corresponding to their charge. Oxygen has a negative oxidation number of -2, except in a peroxide and when reacting with fluorine. Hydrogen has a +1, except in metal hydrides. Fluorine has a -1. Chlorine has a -1, except combined with oxygen. Next lesson, we will have to go into the detailed calculations of oxidation number in a compound. Thank you very much. Have a nice day. Bye-bye.